Okay, so elemental properties, periodicity. So which of the following statements regarding properties of atom is false? So they are asking which one are false. The covalent radius of iodine atom is smaller than its van der Waals radius. So this picture depicts directly from your uh, research book. So you can identify what is the difference between the covalent radius and van der Waals radius. Okay, so covalent radius means when you have iodine that is bonded through the covalent bond, and when you have another iodine, just say I2, which is again bonded, and when there is covalent interaction between one I2 molecule towards another I2 molecule. So this is the bonded distance and this is the non-bonded distance. And this non-bonded distance which have the interaction between these two iodine molecules, we call this as the van der Waals interactions. Okay. So bonded means electron sharing. So it always will have some distance between the two nuclei. So there is this amount of distance within the nuclei. In fact, it is 266 picometers. But when you go to the van der Waals radius, automatically you need to understand this is the non-bonded distance. So basically it should be very large. So here it says the covalent radius of the iodine atom is smaller than the van der Waals radius. So in fact, this is correct. Okay, so identify the difference. Covalent means bonded distance, van der Waals means the non-bonded distance. The first electron affinity of oxygen atom is greater than nitrogen. So you can imagine when they are asking about this electron affinity comparison, they always use this oxygen or nitrogen or halogens with other elements because halogens will have higher. So consider about the electronic configuration. Nitrogen is 7, oxygen is 8, right? So think about arranging this electron. So one of these will have the partial stabilized electronic configuration. For an example, 1s2, 2s2, 2p3. So nitrogen will have 1s2, 2s2, 2p3 basically. Okay, but here it will be 2p4. So 2p3 means it is somewhat stabilized. So to break that, it's not easy. But here there is no problem because it is already higher than the 2p3 configuration, 2p4. So it will have some affinity to, in fact, it has an affinity of getting 2 electrons. But the first electron affinity, they're asking about the first electron affinity. So here it is mainly like 2p4. 2p4. So here it is nitrogen is 2p3. Okay, nitrogen is 2p3. So basically it's a partially stabilized state in the p orbitals, right? So you have like 1, 2, 3. Now you are going to break this one, but here it is already broken, 1, 2, 3, and another one is there 4. So gaining an electron is not a problem there. Right, so this is also correct that ionization energy of an atom is determined by only by its nuclear charge and radius, or in determining the ionization radius, because this ionization energy in return will tell you about the idea of this atomic co-ionic radii basically. Okay, because when you remove the outermost electron, basically it becomes your ionization energy. Here it is negatively charged, but when you can consider it for the positively charged as well. So always remember, when you are considering about this ionization energy, you need to have nuclear charge, that is the effective nuclear charge actually that is acting on the outermost electron, and as well as the radius, which determines the distance between the electron to the outermost electron to the nucleus, and plus there should be what, as I told you, the shielding parameter. Okay, the shielding parameter, which is also called the screening effect. Okay, so you need to consider about screening when you are determining the ionization energy, because what you have to know here is there is a nucleus in the middle, there is an outermost electron, so you are going to remove it. So one thing is the distance, because it determines the energy of the electron. Second thing is nuclear charge, because it determines the how much attraction there is towards this electron. And the third one is the surrounding electron, which will prevent this nuclear charge, effective nuclear charge, and shield the new electrons. So those three factors should be necessarily considered. Okay, so this is wrong because it should be we have to consider this screening as well. Okay, so the nuclear charge felt by the valence electron in a lithium atom is less than 3. So when you have lithium, so basically this is lithium nucleus for an example, let's say. So lithium is 1s2, so there will be one electron here, and one electron here. So what is the meaning of nuclear charge felt by those valence electron is less than 3? So this is directly related to the third statement. Why? Because if you have only lithium, considering the electrons, think about it. Lithium has 3 electrons and lithium has 3 protons, and there will be this nuclear attraction that is happening towards this electron. So if you give this nuclear attraction 1, 1, and 1, in fact, the nuclear charge will be 3, right? There are 3 attractions that is basically happening. So it should be 3, okay? Because it is attracted by this one, which is very important, this one and this one. Don't think that by the valence electron. So this is only the valence electron, okay? But when you consider about the nuclear charge, they are asking about the valence electron in the lithium atom is less than 3. First, we will consider about the overall. So overall is this has these effective nuclear charges that is acting on these electrons. So basically there are 3 electrons. So it should be generally 3. But don't forget this factor, screening. So although this outermost electron, okay, has some effective nuclear charge towards this lithium nucleus, there are these 2 electrons that is going to repel this outermost electron from them. Okay, so always the electron will feel the resultant. What is the resultant? The attraction between the electron and the nucleus minus the shielding parameters from these 2 electrons. Okay, so automatically it becomes less than 3. There is no problem. In fact, when you consider this electron as a lone electron, it is even less than 1. Since he have the 2 other electrons as well, so there is this, they are given to consider as 3. Okay. And the last one is electronegativity of carbon atom is same as sulfur, so it is very straightforward. Carbon is also 2.5, sulfur is also 2.5 in the Linus Pauling scale, so there is no problem in that. So the point to get, remember these 3 factors are that determines the ion free